All right, classify each of the following as a pure substance or a mixture. If a mixture, indicate whether it is homogeneous or heterogeneous. First up is air. What is air? A pure substance or a mixture? Well, air is actually a mixture consisting of multiple different elements and compounds. On Earth, air is actually 78-ish% nitrogen and about 20% oxygen, which we use as human beings to breathe. And there are also some other trace molecules and elements like carbon dioxide, water vapor, and even argon that are in the air. So air is definitely a mixture. Now, is it a homogeneous mixture or a heterogeneous mixture? Well, a homogeneous mixture means that it is uniform. It all looks the same. All the atoms and molecules are evenly spread out and mixed, whereas a heterogeneous mixture is non-uniform. It is not evenly mixed. So we can't really see air ourselves because it's transparent, it's see-through. But if we, say, zoomed in on a particle diagram, we would see all the different atoms and molecules evenly mixed and spread out. So that would mean that air is a homogeneous mixture. Next example is tomato juice. Now, there is no tomato juice molecule or element, so tomato juice is also a mixture of many different things. You might have proteins, vitamins, minerals, all of that mixed together makes tomato juice a mixture. Now, looking at a glass of tomato juice, you might think that looks pretty uniform. It looks all pretty much the same. Tomato juice is actually something that we call a suspension, in that if you let tomato juice sit for a while, say you mixed it up a lot and it pretty much all looked the same, but if you let it sit for a while, you would actually potentially start to see some separation, maybe some different particles would kind of collect near the bottom, maybe on top. It would kind of depend, but it's actually a heterogeneous mixture. And if we looked at a particle diagram of something like tomato juice, we would potentially see kind of sections where you would have maybe the same particles all forming together, and you wouldn't get that even distribution of everything. It would definitely be non-uniform looking at it on the atomic level. So tomato juice is heterogeneous. The third example is iodine crystals. So iodine might kind of look different if you're looking at it in person. You might see some darker purple, maybe some black. Depending on how the light is reflecting off it, you could think, oh, maybe there's some different things here. But the key word is iodine crystals. Iodine is actually an element. It's going to be on the periodic table of elements. So iodine is going to be a pure substance. And if we looked at some iodine crystals on the atomic scale, we would only see the same type of atoms. So iodine is a pure substance, specifically an element. All right, last is sand. Now, by looking at a picture of sand, we can clearly see the different colors. So that would definitely indicate that sand is a collection of many different minerals, compounds, things like that. So we wouldn't necessarily have to look at a particle diagram for sand because you can pretty much tell. But if we did, again, like tomato juice, you would kind of see this separation of molecules there, where one type would kind of be concentrated in one area and another type concentrated in a different area. So sand is also a heterogeneous mixture. All right, there you have it, classifying substances as pure or a mixture, and if it was a mixture, is it homogeneous or heterogeneous? Alright, if you want to see another example, click in the top right. Please like this video if it helped you in any way. Feel free to look in the doobly-doo below for additional help and resources. Please subscribe and ring the bell to get notified for new videos. And thank you so much for watching.